All right, so this might be fun. Let's say a multiple choice conceptual question. A transformer can only operate with an AC voltage source. True or false? The short answer would be true. It needs an AC source. The long answer is no. You can do it with DC. A transformer only functions if the voltage is changing, right? Or if the current is changing or the flux is changing. It's an EMF or a Faraday's law kind of property. But what about in a circuit that's DC, but right there when you first flip a switch, right? That transient behavior could cause the transformer to do something. When it reaches steady state, of course, it'll be completely inert and do nothing. So let's invent a device that looks like a battery, and we'll put it on a switch. And I'll give it some wrap of coils and wrap it around maybe some kind of ferromagnetic material. I don't know what it is. Maybe it's just an iron nail or something. Okay? And so let's say it has some number of turns. I don't know how many. Let's say maybe just 4. Okay, we have to have a secondary, so this will be the number of turns, I guess, in the primary. Let's build a secondary that's got a ton of turns. And where do I want the leads to go? I guess nowhere. Let's just let them dangle. And we'll split them apart by about, I don't know, maybe 1 millimeter, right? So I just got 2 dead leads that hang nowhere. Let's put 250 turns in that one. And let's hook it up to a battery, maybe a 12-volt battery, just for funsies. A couple questions for you. This is obviously a step-up transformer. What would be the voltage output over here on the secondary side? So I guess we need to think about the transformer equation, right? And I think the step-up transformer equation, gosh, now I don't remember. I think it was VP over NP equals VS over NS. And I hope that's right because I don't want to go through the trouble of rederiving it. Yeah, I hope that's okay. All right, and we're trying to find VS, right? So VS is, I guess, VP times the turn ratio, NS over NP. And yeah, this will be a step-up transformer. So my primary voltage was 12. My secondary, oh, I didn't mean 250, I meant 1,000. My bad. I wanted the turn ratio to be 1,000 or 250. So I'll make that 1,000 turns over 4. So that gives me 12 volts times 250. It's just a multiplier, right? So help me figure out this value. Like what, I guess, what is that? The mental math I'm not great at. I mean, I'll be the first to admit it. So why don't I do some tricks to help me through? I'll multiply the top and the bottom by 4. And I'm only doing that so that this thing turns into 1,000, right? So it's really easy for us to see. Right? And then this is what? 12 over 4 is 3 times 1,000. I get 3,000 volts, which you could have done much more directly with a calculator. That's my output on the secondary. So what kind of a device is this, and what was the point of doing that? Well, what do you think would happen? I've just got 2 spots out here, and they've got a distance between them of 1 millimeter, so maybe we could figure out the electric field, right? That's a certain change of volts over D, right? And this is a rough estimate, assuming it was constant, which it's probably not, right? They look like 2 point charges. But we'll kind of approximate. I've got 3,000 volts over 0.001 meters. So that's 3 decimal places. That'll take me up here and give me 3 times 10 to the 6 volts per meter. And where have we seen that number before? It's the electric breakdown of air. So I might ask you one more time. this very crude device that I invented, what is it? Think hard about it and think of what this thing means.
It's a spark plug.